Okay, this is part 2 of going over module 7. We are going to be starting out with the topic finding an output of a function from its graph. We did this in MAT137, but let's just go over it again. So it says finding an output from a graph. So you're given a graph, and then it says we need to find h of 1. So we're looking for the y value when x is 1. So we look at where x is 1. We find that point on the graph, which is right here, and we see that that outputs at a y value of 2. So h of 1 would equal 2 because this is the point 1, 2. Same thing over here. The graph of the function f is shown below. Find f of -4. So we go to -4 on our x-axis. We find the point on the graph that lines up with, and this is the point -4, 1. So it outputs to +1. So f of -4 is 1. For the next topic, finding inputs and outputs of a function from its graph, it's more of the same, except we're going to be asked the opposite as well. So we have a graph below, and we have to find one value of x for which h of x equals 0. Now they're giving us the output of 0, and we need to find the x value that goes along with the y value. So here our y value is 0, and I only see one point on this graph who has a y value of 0. That is the point -4, 0. So our answer here would be x would equal -4. So h of -4 equals 0. Then they also want us to find h of 0. That's the same thing we did up here. We want to find the y value when x is 0. That looks like it is -2. So when we're looking at h of x equals 0, that 0, because it's after the equal sign, is a y value. So we're looking for the x value that goes along with the y value of 0. And when the 0 is on the inside, when that number is on the inside, we're looking for the value of y that has an x value of 0. Okay? So that's h of -4, so -4 equals 0. And then h of 0 is -2. Same thing over here. They want us to find h of 2. So we want to find the y value when x is 2. So that looks like it is also 2. So h of 2 equals 2. And then they want us to find one value of x for which h of x is 4. So they're giving us a y value here. We have to give them the x that lines up with that y. So our y is 4 here. We go over, and it's that point right there. And that lines up to 3. So h of 3 equals 4. So this point right here would be the point 3, 4. So h of 3 equals 4. So the x value would be 3 that you would type for your answer. Now, a little interesting here, we have a possibility that there would be more than one x value for each y. That's okay, that's still a function. We just can't have more than one y value for each x. So h of 2, that's the same thing we've been doing. They want to know the value of y when x is 2, and h of 2 would equal -2. Now they want to know h of x equals -4. And as you can see here, all right, we have, this one is actually only 1. We're talking about that vertex of that parabola, that bottom. So when h of x equals -4, x can only be 0. So we're looking at h of 0 equals -4. So x would be 0. I'm wondering if this one has it. Yes, this one is a little bit different. It's a unique situation. So same thing here, f of -2. So -2 has an output or a y value of 3. So f of -2 equals 3. And they want us to find f of x equals -1. So if we find the y value of -1, we have this point here, and we also have this point here. So it is possible for there to be two x's representing of one y value. So we have two possible answers. That's why they say find one value. You only have to put in one value. So it looks like here that f of 0 would equal -1, and f of -3 would equal -1. Now, you don't have to put in 0 and -3, just one of them, but know that there is two possibilities here. So when you have a number on the inside, you're looking for the value of y that matches up with that x. When you have a number on the outside after the equal sign, you're looking for the value of x that has a y value of that number. Okay? Let's move on to number 14. Here we're talking about domain and range again. Domain and range from a graph of discrete relation. So domain and range from this particular graph. So it says the graph of the relation S is shown below. Give the domain and range of S. Write your answer using set notation. Okay. So domain. What we need to do first is we need to come up with the x values of all of these points, starting with our lowest x value and ending with our highest x value. So this dot, we go from left to right when we're talking about domain. So this dot has an x value of -4. So we make our curly little bracket there. And then we have -4, comma. We move over to the right. And it looks like the next one has an x value of 2. And then we have two dots that have an x value of 3. You don't need to write 3 twice. So it would just be -4, 2, and 3. So -4, +2, and +3. Would this be a function? No, because it would fail the vertical line test. You don't need to answer that in this one, but it's just good to know. Now our range is the set of all y values. We're going up and down. So we're starting at the bottom and working our way up, looking at y values of this. They do not need to correspond to these points in the same order. So we start with our lowest y value. Our lowest point is here. Our lowest y value is -4. Then we go up. We have a y value of 0, then 1, then 3. So we work our way up, -4, 0, 1, and 3. Same thing in our next problem. We have a different graph that shows a relation S. So our domain, we put a curly bracket out for that set notation. We start with our lowest x value. So here we have an x value of -4. Then we have two x values of -3. We only have to write it once. And then we have an x value of 2. So it's very important here that we start from our lowest and end with our highest. So -4, 3, and 2. Our range is the y value. So we're going to start with our lowest y value, which is -3, then -2, then a y value of 0, and then a y value of 2. So our domain is -4, -3, 2. Our range is -3, -2, 0, and 2. Our next topic, we are talking about x and y intercepts. Pretty easy stuff here. It says the graph of a function is given below. Give all y intercepts and x intercepts shown. So let's start with our y-intercept. That's where we cross our y-axis. Our y-intercept is right here. So we have a y-intercept at the point 0, 2. And then we have actually 2 x-intercepts. You're only ever going to have one y-intercept, but you could have more than one x-intercept. So that's where we cross our x-axis. So we're looking at 2 and 4. So these would be the points 2, 0 and 4, 0. I'm not sure if Alex is looking for the coordinate point or just the x values and y value where they're located. But y-intercepts always have an x value of 0, and x-intercepts always have a y value of 0. So over here on this other graph, we see that it does have a y-intercept. It just so happens to be the same y-intercept as our last one. So our y-intercept is the point 0, 2, but we do not have any x-intercepts. So we would just write no x-intercepts. Okay, or click the button on Alex that says there are none or something like that. I don't know what they have you do for that. All right. So x and y intercepts, very easy to identify. Okay. Next, we have some graphing review here. So we're going to be going over graphing a function of the form f of x equals ax plus b, that's integer slope, that's y equals mx plus b. Then we're going to be going over the same thing, but with a fractional slope, that would be this one. And then we're also going to be going over graphing a function with absolute value equations in the form of y equals a times the absolute value of x. That will be those. So these 4 problems are actually 3 topics. Topic 1, the first topic, second topic, and then these 2 would be the third topic. Okay. So here we would have a x and y axis. I didn't write those in for you, but you could just make an x and a y axis. We are going to be starting at the y-intercept of 3, 1, 2, 3. And then we're going to be following the slope of -4. So the slope of -4 would be -4 over 1. So we would go down 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. But instead of down and right, I can also go up 4 and left 1. I believe Alex just wants you to make 2 points, and then you'll be good. Here, same concept, except we have a fractional slope. So I am going to draw in my x and my y axis. Doesn't really matter where it is. I'm going to start at my y-intercept of -4, 1, 2, 3, 4. And then my slope can either be -2 over 3, or it could be 2 over -3. So this would be down 2 and right 3, or up 2 and left 3. So from here, we're going to go down 2, right 1, 2, 3. Now I ran out of room on my graph. So, or then I could switch it and go to up and left 1, 2, 3. Either way, I have the negative slope of my graph. Okay, now absolute value. This might be something brand new to you. You might have done this in Algebra 2. It's not bad. Let's see what we have. We're only going to be doing the easy ones like this, and that's it. I wouldn't worry too much about it. It's pretty easy. All the absolute value functions that we're going to be doing will have a vertex through the point 0, 0. So you always want to draw in the origin then this negative out front, or whatever's out front here, is going to be your slope of your right side. So in this case, this is really -1 times the absolute value of x. So our slope of our right side would be -1. So we would go down 1, right 1, down 1, right 1, down 1, right 1. And our right side would have that slope of -1. Now our left side would have the opposite way. It would be reflected over it. The absolute value, you want to make a V shape. Okay. So instead of going down 1, right 1, we're going to go down 1, left 1, down 1, left 1, down 1, left 1, and keep going. So we end up with a V shape. Okay. The absolute value, you're always going to end up with a shape of a V. That absolute value means that you can never be negative on that, which is why it's not a straight line. Right? V's curve down the other way. Okay. Same thing here with this one. Just so happens it's another negative number out front. It doesn't have to be a negative number out front. We're going to start at 0, 0. And our slope of the right side is -3. So we're going down 1, 2, 3, right 1, down 1, 2, 3, right 1. And on the left side, we would go down 1, 2, 3, and left 1, down 1, 2, 3, and left 1. So we end up with a skinnier V. Okay. Just for fun, I'm going to make a new problem, which is the absolute value of, so y equals 2 times the absolute value of x, just to show you a positive. So you start off with the same origin here, that, and then you would follow the slope of 2. So I'd go up 2, right 1, up 2, right 1, up 2, right 1. And then to get the left side, I go up 2, left 1, up 2, left 1, up 2, left 1. Okay. So we have y equals -3 times the absolute value of x. That would be down with a slope of -3. And then we have y equals 2 times the absolute value of x. I just threw this in here as an extra one. We go up 2, right 1 on the right side, then up 2, left 1 on the left side to form the V. Just wanted to show you a positive one. Okay, that's it for this video. I'm going to be posting the third video of Module 7 tomorrow. So start working in Alex, get a lot of your topics done, and we'll talk soon.